Buckle up, cosmic explorers, as we plunge into the mind-bending mystery of the Great Attractor, a hidden force tugging entire galaxies, including our own, toward an unseen destiny in the depths of the universe. Welcome to a thrilling odyssey through the cosmic currents, where we'll unravel the enigma of this gravitational juggernaut, probe the colossal structures shaping the universe's flow, and chase the tantalizing clues about what lies at its heart. Is it a supermassive cluster, a dark matter behemoth, or something stranger still? How does it steer the fate of galaxies across billions of light-years? And what groundbreaking discoveries are bringing us closer to unmasking this cosmic titan? Get ready for an epic adventure packed with cutting-edge science, awe-inspiring revelations, and cosmic intrigue that will keep you hooked from the first tug to the final truth. Let's dive into the mystery of the Great Attractor and find out what's pulling galaxies toward it together. Picture the universe as a vast ocean, not of water, but of galaxies, clusters, and voids stretching across billions of light-years. Amid this cosmic sea, galaxies don't drift aimlessly, they flow in streams, drawn by gravity toward massive structures. One such current, discovered in the 1980s, is pulling our Milky Way and thousands of neighboring galaxies at speeds up to 600 kilometers per second toward a point 250 million light-years away in the direction of the constellations Centaurus and Norma. This invisible force, dubbed the Great Attractor, exerts a gravitational pull so immense it warps the motion of galaxies across a region spanning 300 million light-years. Unlike nearby clusters like Virgo, a mere 60 million light-years away, the Great Attractor lies hidden behind the Milky Way's dense disk, in the zone of avoidance, where stars and dust obscure our view. Its influence reshapes our understanding of the universe's large-scale structure, revealing a dynamic cosmos sculpted by gravity. As we embark on this cosmic quest, you'll see how the Great Attractor challenges our maps of the universe, hints at unseen masses, and sparks debates about the nature of gravity itself. Doesn't the idea of an invisible force steering galaxies ignite your curiosity to uncover its secrets? The Great Attractor's discovery emerged from a cosmic puzzle in the 1970s. Astronomers studying the cosmic microwave background, the relic radiation from the Big Bang, noticed a dipole anisotropy, a slight temperature difference across the sky, suggesting the Milky Way was moving at 600 kilometers per second relative to this primordial light. This motion, far faster than expected, couldn't be explained by the Virgo cluster alone, which exerts a pull of about 200 kilometers per second. In 1986, a team led by Alan Dressler, part of the Seven Samurai collaboration, mapped galaxy motions using redshift surveys, measuring Doppler shifts in galaxy spectra. They found that galaxies within 300 million light-years, part of the Laniakea supercluster, were streaming toward a gravitational anomaly in the zone of avoidance. Dressler coined the term Great Attractor for this unseen mass, estimated at 10 to the power of 16 solar masses, equivalent to tens of thousands of galaxies. By 1988, surveys like the Able Cluster Catalog hinted at massive clusters like Able 3627, or the Norma Cluster, near the Great Attractor's position. This discovery, detailed in Dressler's 1994 book, Transformed Cosmology, revealing hidden forces shaping the cosmic web. How did a subtle redshift uncover a cosmic giant? Let's map the Great Attractor's domain. Located at redshift z equals 0.016, about 250 million light-years away, it lies in the Laniakea supercluster, a structure of 100,000 galaxies spanning 520 million light-years, defined in 2014 by Brent Tully's team using cosmic flows, 3 data. Laniakea includes the Virgo cluster, Hydra Centaurus, and Norma clusters, all converging toward the Great Attractor's coordinates at right ascension 10 hours 32 minutes, declination -46 degrees. The zone of avoidance complicates observations, as the Milky Way's disk blocks 20% of the sky. Infrared and X-ray surveys, like those from the 2025 Gaia mission and XMM Newton, pierce this veil, revealing clusters and galaxy walls. The Norma cluster, with 600 galaxies, is a key player, but its mass alone, 10 to the power of 15 solar masses, falls short of the Great Attractor's pull. Simulations suggest a larger structure, possibly a supercluster or dark matter overdensity, drives the flow. The cosmic web, filaments, walls, and voids, channels galaxies towards such attractors, with Laniakea's flow converging like rivers to a basin. Isn't it wild how hidden structures steer the cosmos? The Great Attractor's nature is a cosmic conundrum. Early theories pointed to a massive galaxy cluster, but surveys found no single object massive enough. The Norma cluster, studied via 2025 Meerkat radio observations, hosts thousands of galaxies and hot intracluster gas at 10 to the power of 8 Kelvin, emitting X-rays. Yet, its gravity accounts for only 10 to 20% of the needed mass. Dark matter, invisible but 5 times more abundant than normal matter, is a prime suspect. A dark matter halo, perhaps 10 to the power of 16 solar masses, could amplify the pull, consistent with lambda CDM cosmology, where dark matter scaffolds the cosmic web. Alternative theories propose a supercluster complex, with Norma as one node, or a gravitational anomaly from primordial density fluctuations. Exotic ideas, like modified Newtonian dynamics or a local underdensity pushing galaxies outward, are debated but less favored. In 2025, DESI's spectroscopic survey maps galaxy motions, refining mass estimates. What mysterious mass tugs at the cosmos? The cosmic flow's dynamics are complex. Galaxies move in a Hubble flow, expanding with the universe at 70 km per second per megaparsec, but local gravity creates peculiar velocities, deviations from this expansion. The Great Attractor's pull induces velocities of 300 to 600 km per second, measured via redshift distortions. Blue shifts toward it, red shifts away. The Cosmic Flows, for dataset, released 2025, uses supernovae and Tully-Fisher relations to map these motions, showing Laniakea's galaxies converging like water in a gravitational well. Beyond 300 million light-years, the flow weakens, overtaken by the Shapley supercluster, 650 million light-years away, with 10 to the power of 17 solar masses. This interplay suggests a hierarchy of attractors, with the Great Attractor a local player in a larger cosmic game. Simulations, like Illustrious TNG in 2025, model these flows, predicting dark matter's role. How do these currents shape the universe's architecture? Observing the Great Attractor is a technological challenge. Optical telescopes struggle through the zone of avoidance as dust, extincting light by 90%. Infrared surveys, like 2MASS, reveal galaxies behind the Milky Way, while radio telescopes, like Parkes and Meerkat, detect neutral hydrogen (HI) emission at 21 centimeters, mapping galaxy kinematics. X-ray observatories, like Chandra, image hot gas in clusters, estimating masses via gravitational lensing, light bending by massive objects. In 2025, Erosate's X-ray survey catalogs 100,000 clusters, identifying candidates near the Great Attractor. Gravitational wave detectors, like LIGO, could catch mergers in dense clusters, though none are confirmed yet. These multi-wavelength approaches peel back the veil, but the zone's opacity limits precision. Future missions, like SphereX in 2027, aim for all-sky infrared maps, promising clarity. What tools will finally unmask this cosmic force? The Great Attractor's role in cosmology is profound. It anchors Laniakea, defining our cosmic address. Its mass probes dark matter distribution, testing cosmological models. Galaxy flows trace the cosmic web, mapping filaments and voids. A 2025 Nature study used FRB dispersion to estimate baryon density near the Great Attractor, confirming CDM predictions. It also tests gravity. Does general relativity hold at these scales, or do alternatives like MOND explain flows? The attractor's pull influences our cosmic perspective, calibrating distance ladders via peculiar velocities. Its study bridges galaxy formation and large-scale structure. How does one region redefine the cosmos? Mysteries persist. What's the Great Attractor's true mass and extent? Is it a single object or a diffuse overdensity? Why does the Norma cluster fall short? Could a larger structure, like a hidden supercluster, lurk? Planet 9 analogies suggest unseen masses perturbing orbits, with 2025 Rubin Observatory searches probing distant influences. The zone of avoidance's opacity hides answers. Could exotic objects, like primordial black holes, contribute? The attractor's place in the cosmic hierarchy, does Shapley dominate, is unclear. These questions fuel research, with answers on the horizon. Future prospects excite. Rubin's 2025 to 2035 survey will map 20 billion galaxies, refining flows. SKA's radio surveys, phased in 2025, will detect HI in millions of galaxies, piercing the zone. Euclid's weak lensing maps, by 2028, will trace dark matter. If gravitational waves align with the attractor, multi-messenger astronomy will pinpoint its core. Could we map its heart in a decade? What does the Great Attractor mean for us? It pulls our Milky Way, linking us to cosmic flows. Your atoms, forged in stars, ride its current. From Dressler's surveys to SKA's scans, curiosity unveils it. We're cosmic sailors, navigating gravity's tides. As we near the end, let's gaze ahead. The Great Attractor, pulling galaxies toward it, reveals the universe's structure, dark matter's grip, and gravity's dance. New telescopes, data, and dreams will unmask it. What lies at its heart? How will it reshape our cosmic map? The universe flows, full of wonder. What questions stir your mind? Thank you for joining me on this epic dive into the Great Attractor, what's pulling galaxies toward it. I hope your curiosity blazes. If you love this cosmic adventure, hit that like button, subscribe, and ring the bell for more journeys into the unknown. Drop your thoughts in the comments. What blows your mind about the Great Attractor? What mystery should we explore next? Until then, keep looking up, keep wondering, and let's unravel the universe together. See you in the next video, Cosmic Explorers.